Malachi, let's go. We support you, Malachi.
Nah, bro.
Hello, Malachi.
Okay, if you have other things to talk to about, that can be after class. I love that everyone's supportive and that we have a positive classroom environment. Okay, back to the notes. Okay, so for review, there are 3 different types of tectonic plates that we need to know about for the test. First one are divergent plates. Those are plates that are going away from each other. So maybe think like slime. You have slime, right? And you're pulling it away. So it's eventually going to break in the middle, right? Same thing here with our Earth, and when the plates are moving away from each other, there eventually become like a crack or like a hole in the surface, and that allows for magma to kind of seep through and kind of set itself there and potentially form a volcano. The opposite of divergent plates are convergent plate boundaries, and those are plates that are going towards each other. And since they're going towards each other, they're somewhere that the land mass would have to go, right? So there's only one way, which is up or down. So some part of the land will go up and form the mountains, and then some of the piece of land of the plates will go down, deep down, further on the earth, creating kind of like an underground kind of hole. And if we go back to the last couple of class notes, with that happening, here we see right here when that convergent plates, when they both hit each other, one's going to go down, and going down creates a subduction deep down and also gives place for lava and all of the molten rocks to stay there, and eventually also going to erupt and form volcanoes. So either way, divergent or convergent, eventually we'll have volcanoes. It's either if it's up on the surface or down beneath the surface, there will be volcanoes forming. The third type of plate are transform boundaries, and it's when the tectonic plates slide past each other. So they're minding their own business. They're parallel to each other, but they're going different ways. One's going right, one's going left. So there's no type of pushing or pulling against each other. But this ultimately creates earthquakes because of a movement in the plates. Oopsie. so we can add more things. So with all these changes that we see, like that ultimately causes volcanoes or earthquakes, that's why it's important to learn about plate tectonics, because it can ultimately affect us and how we live. And a natural disaster that we need to keep an eye out for, learn more about, see what we can do to prevent, or maybe tell. So every day there are more scientists trying to figure out ways of how to kind of predict when these things can happen or even prevent it from happening. And that'll keep on going. So maybe one day, maybe one of you can find out a way to prevent these natural disasters from happening. So with the movement in plates, so tectonic plates are always moving. So that's why it creates pressure, because they're hitting against each other, they're moving up against each other. So ultimately, the pressure will need to be released somehow. Kind of like with the volcano, let's say like you have a bottle of soda, right? And you're shaking it, you're creating pressure, right? The movement's creating the pressure, and eventually the volcano will explode from the pressure. Just like how if you keep shaking a bottle of soda, eventually with all that movement and the pressure building up, it will explode. And let's see. Oh, that's really. And then same thing with earthquakes, movement of plates create pressure. So some volcanoes, the movement, which is also called subduction, the movement during the oceanic crust. So these are the volcanoes that are deep underground in the ocean. The movement also makes the magma erupt. So I'll go back to the notes, but just to go back on this picture here. So this volcano is up, but if we go, there are volcanoes deep underneath the ocean, like we saw during with this picture of the Pacific Ring of Fire all over the oceanic crust. So just like how waves are moved, when there's a force like wind or a movement, maybe in the plate tectonic too. When there's a movement in water, that'll make the water flow and move around. So the moving around will also happen and affect the lava underneath the volcano. And with that moving, it's like shaking that soda bottle again. And then the volcano will eventually erupt. So similar to like our last point with the subduction in the oceanic crust. So the oceanic crust is also like plate tectonics, just two different ways to say them because the crust is also broken up like the plate tectonics are. Let me make this picture a little bigger. So underneath the earth, in the mantle, the heat currents called convections are moving around in a circular motion, and that also creates movement, which makes the plates, the tectonic plates, also move around. So that this is also contributing to the plates moving around. I know, like, we don't feel it right now because it's really a subtle movement, but when we do feel it, that's when it's an earthquake, right? That's like a huge movement. So right now they're just like moving around a little bit subtly. Okay, and 2 more points and then we're done. We're almost done. So all throughout the history of the scientists have been trying to come up with theories on what's happening with the earth. One came up with that the earth is getting smaller over time, that there's a contracting earth. And then another thought of the idea that the earth was getting bigger over time, like earth is expanding. But even with all this movement, plate tectonics, and the earth, there was evidence found that the earth's diameter, so its overall size, didn't change at all. So this evidence debunked these two theories of the contracting earth and the expanding earth. And with science, like a lot of times you're going to be making up hypotheses, theories, just about how the world is going to work. But that ultimately doesn't, sometimes it's going to be wrong, like these two. And that's okay because, like, once you find out that it's wrong, you can move on, think of another theory, and that'll bring you closer to what's really the right answer that's happening. So it's okay to have wrong answers. Same here, like when you're taking review questions from Blue Kid, or if you're taking your quiz, like you'll get wrong answers, and that's okay because after you get that wrong answer, you'll know which one's the right answer, and in the future, you'll know what it is. And then two theories last that we're going to do. Two more theories is the continental drift, that our continent is always slow, it's always moving. So with the plate tectonics, earthquakes happening, cracks in the earth's surface, that can contribute to continental drift. Remember how we used to be Pangea? We used to be one big continent. Now we're 7 different continents. So that helps support the continental drift. And can I go up like that? And plate tectonics, someone came up with the theory that maybe there are plates underneath the Earth's surface in the crust that's constantly moving. And with the earthquakes and volcanoes and cracks in the earth called faults happening, like they found more evidence to support that plate tectonics truly do happen or truly do exist. Take this out for now. There we go. Okay, and then that'll be it for our notes. Leave it up for a little bit more. If you're done with the notes, go ahead and do your independent work. So that's Unit 4, quiz number 2, quiz 4.2. And ooh, we got a lot of people done. 2, 3. And if you're done with the quiz already, I'll send you a Blue-Git link. Just give me a second. Okay, so I sent all the Blooket links to those that are done. So that should be 4 of you. And those who have your Unit 4 locked, I'll go into checking that. Because it looks unlocked over here. Yeah, it's the weird thing is that it's unlocked on our end. It looks like. Let's see.
me up without an online reservation.